Proceeding to question number 4. Look at the question. It gives the x coordinate and y coordinate of a particle as a function of time, and here we need to calculate the torque acting on the particle about the origin. So we need to calculate the torque about the origin. What we'll do is that the position vector can be calculated, xi cap plus yj cap. So here what we get is, with the value of this, I can calculate our vector is xi cap plus yj cap, and with the help of this, I can calculate v by differentiating with respect to time, right? So that's going to be vx I cap plus vy j cap. Then acceleration, which would be ax I cap plus ay j cap. So there I go. I calculate the velocity, I calculated the acceleration. Once I calculated the acceleration, m into a will give me the net force, and I am supposed to calculate the torque about the origin. So what we'll do is that it's something like this. Here's the coordinate axis, x and y. And at any given point, this is going to be the r vector. And what is the required thing is tau is equal to r vector cross of f, and that's so simple. That will be x I cap plus y j cap cross. The force will be equals to m times a vector. At this level, differentiation of this trigonometric function should not be a difficulty. Cross product should not be a difficulty. You do it, and with an average effort, you can very easily calculate. And the correct option for question number 4 would be option number 3. Now it's time we move to the next question, the 5th question. Question number 5, modern physics, one of the very fertile area of both JEE Mains as well as JEE Advanced. And this is a very straightforward question. The photoelectric effect has been given. The threshold wavelength is 380 nanometer and the incident wavelength of light is 260. Since the incident wavelength is lesser than the threshold, so there would be emission. We need to calculate the maximum kinetic energy of emitted electrons. And just for the sake of calculation simplicity, this has been given 1237 by lambda in nanometer. If you put, you get energy in electron volt. So this is just, a consolidation of Hc. This much is there, and you put lambda in nanometer, you'll get energy in electron volt. This is a fact that we very commonly use in the class, because normally our type of calculation is calculator less, and Hc being a very commonly used thing, so we memorize in this way. So here what we'll do is say, all I need to do is that I need to calculate the maximum kinetic energy, and the maximum kinetic energy would be Hc by lambda minus of Hc by lambda naught. And both the wavelength has been given in nanometer, and if I put Hc as 1237, I will be getting option number 4 as the correct option for this question. It doesn't have any modification, a straightforward calculation one. The 6th question. It is more a mathematical question, and physics is not at all involved. A very smallest degree of physics is involved, more about the mathematical manipulation. It's been said that the resistance of a material, it varies with temperature. Sometimes it increases, sometimes it decreases, but after all, that is of no use here. And log of resistance has been plotted with respect to 1 by t square. And on the basis of this graph, we need to find out the mathematical relationship of variation of resistance with temperature. Fine, let's see. As I said, it is more a mathematical one. What we'll say is that the variation of log resistance versus 1 by t square is given in a straightforward pattern, and this is y equals to minus mx plus c, right? So here I have y as log of RT. Therefore, I get y equals to minus of mx, where x is 1 by t square, plus of c, the typical y-intercept that we use. Now, as I said, in fact, we are done with the question, but it's all a mathematical craft what is required. So as to make the equation a smaller one, we need to zip it. And this is not a difficult thing and something out of the box. It's a regular day-to-day practice that anyone uses in a mathematics. As I said, a bit craftsmanship is required. So here what I'll do is that, I'll put log of r, and this c, when I bring it this side, minus of c, and let me say log of r naught, because r naught is a constant, and that simple constant can be related in terms of log. As I say, that it's just by seeing the option, I am trying to customize and eventually reach in the given format equals to minus of m by t square. A further of craftsmanship is required, and that is going to be c, r by r naught will be e raised to the power minus of m by t square, and m is also a constant. And we know that when it comes to the power of exponent, it has to be dimensionless. So m has to be square of the temperature. This part is a very easy one, and you see that you compare with the given option. Option number 2 is going to be the correct option. That was fine, right? Now let's move to the next question.